Let us study about some characteristic definitions about spherical mirrors. We have studied that there are two types of spherical mirrors. One is a concave mirror in which the outer surface is polished and the inner surface is reflecting. In this situation, the midpoint of the mirror piece, which is a section of a hollow glass sphere, is denoted as point P and is called pole of mirror. And if we talk about the center of curvature for this mirror, if this is point C, as we have discussed, this is called center of curvature of mirror, and the line joining the pole, the midpoint of the spherical mirror and the center of curvature, we call as optic axis or principal axis of mirror. And the midpoint of P and C, which is obviously at a distance r by 2, because if the radius of which the mirror is a part of hollow sphere, the radius of that hollow sphere is r, and this r we call as a radius of curvature of the mirror. This is the radius of that hollow sphere of which this mirror is a part. The midpoint of this P and C, which is at a distance r by 2 from pole, this is written as f, where f is equals to r by 2, is called focal length of this spherical mirror, and this point we term as f, which is the focal point or focus of mirror. This is the same point which we have discussed in previous section, that when parallel rays incident onto the mirror which are parallel to principal axis, after reflection all these light rays pass through focus. So this is a point where all parallel incident rays converges and produces an image. So the distance of focal point or focus from the pole of mirror is called focal length, and the focal length is r by 2, where r is the radius of curvature. In parallel, if the edges of this mirror are considered as AB, then this AB can be written as the aperture diameter of the mirror. Here AB is the diameter of this three-dimensional mirror, which is called aperture diameter of this mirror. Similar to the definitions we have discussed here for concave mirror, we can define the same for convex mirror also. So if we are given with a convex mirror which is polished on the inner surface and outer surface is reflecting, again the midpoint is taken as pole. The line joining the pole and center of the sphere of which the mirror is a part is the principal axis, and the radius would be inside of this mirror. It is r, the radius of curvature. The focal point or focus is at a distance r by 2 from pole. The basic difference in the two cases is the focus in case of concave mirror is a real focus because it lies in front of the mirror, and the focus in case of a convex mirror is a virtual focus because it lies behind the mirror, where light rays can never exactly reach. Those light rays which are parallel incident on the mirror will diverge in such a way that these appear to be passing through focal point. That's why it is termed as virtual focus. And similar to this case, again the diameter of geometric diameter of the mirror is defined as d, which is called aperture diameter. So these are the basic characteristic definitions associated with a concave and a convex spherical mirror.